Hey, pre-calculus class. In this video, we are going to look at some of the exact radian values of the so-called special angles in this circle. The 30, 60, 90 triangles and 45, 45, 90 triangles. Those angles that have reference angles of either 30, 45, or 60 degrees anywhere, like in any of the four quadrants in here, or the angles on the axis, right, that have a side length of 0 that, again, don't really make a triangle. That just have, right, something is 0, so it's going to be 1, -1, 0, some combination of those. We did that in degrees already, and now we're trying to figure out, okay, well, what are the radian equivalents of some of those? Because they come up a lot. So we're going to build off of the knowledge that we already have, right? We kind of talked about the 360 degrees is 2 pi radians because the circumference of a circle is 2 pi r, and the definition of a radian is the arc length for a whole circle. It would be the circumference divided by the radius. So 2 pi r divided by r is just 2 pi. That gives me, like, it takes 2 pi radians to complete this full cycle. Since we know that, we also have, right, this 180 degrees has to be half of that, right? We're just doing math. We're dividing both sides by 2. And that really is what we can do to kind of set some of these other ones, right? Like the next one we might want to look at is what is the 90 degrees, right? Well, if I'm up here at 90 degrees, 90 is just 1/2 of 180. And so 90 degrees is going to be half of pi, right? If I cut both of those in half, I get that 90 straight up at that location. It's there. And I could do the same thing again for the 45 degrees. Right? Like, chop this out and say, right, my 45 degree angle is going to be half of 90. So if I'm at 45 degrees, cutting both of these in half, I got pi over 2 over 2, or pi over 4. 1/4 of pi, right? You could also say, right, that's 1/4 of this, gives me that 45 degree angle. I can do the same thing. I'm going to actually throw back to the 180 over pi part, or not 180 over pi, but 180 equals pi to get my 60 and my 30, right? 60 degrees is 1/3 of this. So if I wanted to get my 60 degree angle here, right, the one kind of coming up here a little closer to 45, it's only 15 degrees away from 45, 30 away from 90. But my 60 degrees, that 1/3, is going to be 1/3 of pi. Right? And the last one that I have is, right, that 30 degrees, which I could either, right, cut this in half, or say 30 is 1/6 of 180. So my 30 degree angle is going to be equal to 1/6 of pi, or pi over 6. So now that I have these kind of foundational ones, this helps me go all the way around the circle. And some people find that radians is actually even easier than degrees, because you can kind of think of it in terms of, like, what fraction of the circle are you, right? I can talk about kind of maybe like where am I at in relation to this half circle, right? If this is 1 whole pi, I'm just trying to think of, like, well, what fraction of this circle am I in? If you're a visual thinker and you can kind of see that, right, if I have a reference angle of 45 degrees in that second quadrant there, like, that's 3/4 of the way to, like, that half rotation, so it's going to be 3/4 of pi, right? So we can make a little table here that I want to do where we have the kind of the degree measure, the radian equivalent, and then what's the revolutions that it represents for this whole circle. And this would just represent the building blocks for everything else. So make kind of a 3-columned table where I have my degrees, what's the radian equivalent, and then what fraction of the whole circle is this? So what, right, call it revolutions. It's really like a fraction of a revolution. So we start with, right, 0 degrees is 0 radians is 0 revolutions. If I step this up, the next important one I get is 30 degrees, which we had was pi over 6, or 1/6 of pi, which is really 1/12 of the whole circle, right? It's 1/6 of the half circle, but 30 degrees is 1/12 of 360. It's 1/12 of the whole revolution, right? A step up, the next important angle is 45 degrees. That's a quarter of my half circle, which means it's 1/8 of the whole circle. And so if I cut this into eighths, I would get this. Then 60 degrees is pi over 3, which is 1/6 of the whole circle. 60 degrees is 1/6 of 360. 90 degrees is a half of 180, so it's half of pi. It's a quarter of the whole circle. And we're not going to do all of the ones in between, at least not in this, right? I don't want to make a whole list of it, but this is just kind of like all of the different, right? 1 pi over 6 is 30 degrees. 1 pi over 4 is 45 degrees. 180 is just pi, which is half the rotation. And 360 is 2 pi, or 1 full rotation. So what I want you to do right now in your notes is to try to make some circles here that kind of go by, let's say, 8th rotations and 12th rotations, because the 45 is kind of it doesn't fit in with the 30-60 piece, but I can make maybe a circle that's broken up by all the 45 degrees, and a different circle that's broken up by every 30 degrees, so 30, 60, 90, 120, 150. So I want you to make 2 different circles here with this that you break out and try to figure out what's the radian equivalent for all of those spots around that circle. So this is what I mean. I'm going to try to cut this up into a pie that's basically 8 slices here, and a different pie that's 12 slices here, and come up with what would the radian equivalent be for each of these, right? So this is every 45 degrees, so 45, 90, 135, 180, 225, 270 around, and this is every 30, 30, 60, 90, 120, 150, 180, and so on. What would the radian equivalents be? And we're trying to simplify, right? So some of these things, there's going to be some, right, like if you have 2/6 pi, you should simplify that down to 1/3, right? So I want you to try to do this quickly yourself, right? Go through, right? I have this out here, right? Say this I know is pi over 4. This I know is pi over 2 up here, but what's this going to be, right? Well, if I think of it as being, 3 45 degrees, I can say, well, this is 3 pi over 4, so it's going to be 3 pi over 4, right? Then what's that? Well, we already have my 180 degrees, I know is equal to pi. What's this one down here? Well, it's going to be another pi over 4 past pi, or I can think of it being 5 slices of this. Right? Got 1, 2, 3, 4, 5 pi over 4s, and that's really what I would write. Right? If I added on another one, I would get down here at 6 pi over 4, but that's not really how we would write this, because that's not the simplest fraction, right? You can also think of 270 as being 3 90s to get there, so it's 3 pi over 2s, and that's what I would write. It's 3 pi over 2, right? It is 6 pi over 4 if I'm, what am I doing there? 6 pi, right, over 4, but this is my simplest fraction, just like, like my pi is really, 4 pi over 4, and I can think of pi over 2 as being 2 pi over 4, but we don't have those, right? Like those are not my simplest forms. But it does help me, when I'm trying to think about, this is really just counting up by pi, 1 pi over 4, 2, 3, 4, 5, 6. This one here would be 7 pi over 4, right? And that doesn't simplify. This would be 8 pi over 4, but we really just say, that's 2 pi. Right? And I can do the same thing for my 30 degrees and 60 degrees, right? So my 30 is pi over 6, and we set out already my 60 is pi over 3. It's really 2 pi over 6. And again, if that helps you count, right? Like I'm just going to count everything around here is going to be by pi's over 6's. Right, this is pi over 2. This is 3 pi over 6. This is going to be 4 pi over 6. But 4/6 I can simplify down to 2/3. So it's 2 pi over 3. Or, right, if this is at 120, it's 2/60. So that right there is 2 pi over 3. Right. This one would be 5/6 pi. Right. So finish out the rest of that on your own quick. And so you should have something that looks kind of like this. I color-coded a little bit for the pi over 6s just to say, right, all of these pi over 3s, right, if it ends with that 3 in the denominator, it's going to be one of those 60-degree reference angles, which is useful to know when you're trying to think of, right, what's the u, v, and r coordinates. If it has a 3 in the denominator, you know that the u is going to be shorter than the v. Right? If it has a 6 in the denominator, you know that the u is going to be bigger than the v. So each of these, the 30s and the 60s, right, the 3s and the 6s in that denominator, is going to be a 30, 60, 90 triangle. So the 1, 2, square root 3. But there's some tips and tricks that you can have to know, like, right, if it has a 3 in the denominator, right, the vertical piece is going to be the root 3, and the horizontal piece is going to be the 1. And if it has a 6 in the denominator, vice versa, I know that the v is going to be the short side, the 1, and the u is going to be the long side, the root 3, if the radius is 2. So this is not something you necessarily need to memorize, right? Like going around, because you can kind of figure out, right, like where are these things. So let's do a couple of examples of what this looks like in the book, right? How they'll ask you, right? But you should be able to find out, like, if the book asks you what is the tangent of 11 pi over 6, you should be able to come up with that fairly quickly by connecting it to those 30, 60, 90s and the stuff that we learned back in chapter 2. So a few examples of how I kind of think about this. What if I want to find, let's do that one, the tangent of 11 pi over 6. And let's say that I'm not looking directly at this circle up here, so I don't know, right, exactly where it is. Right. I can kind of do some thinking in my head to try to figure out, like, right, how am I going to get there, right? So a few things I can do. Just try to think, like, if I have 11 pi over 6, there's two ways I can think about this. One is to say this is, right, 11 pi over 6s, right? Like, where is this going to be at in my degrees here? Well, I know that pi over 6 is 30 degrees, so this is 11 times 30 degrees, which is going to be 330 degrees. Another way that I could kind of think about this is to say, well, I know that 11 pi over 6 is just 1 pi over 6 in front of 2 pi. Right? Like 12/6 is 2, so this is just pi over 6 before 2 pi, or 30 degrees before 360. So that would also let me know that I'm at 330 degrees. Or you can just think about it in terms of your rotations, right? Like, I'm 11/12ths of that full rotation. And so knowing where that is on the circle lets me kind of know, okay, I'm dealing with a 30, 60, 90 triangle in quadrant 4, just underneath that 360 degrees. So I want to go in and right, maybe sketch this out, right? What does this look like? I'm dealing with 330 degrees. So that's down here in quadrant 4. And I know I have it's that 30, 60, 90 triangle. So it's the 2, root 3, and 1. And I know this is the short side because the 30 degrees, right, is the shortest angle in that triangle. It has to be across from the shortest side. Then I go in, isn't there anything negative in this location? Right? Well, yeah, I'm below the axis, so my vertical has to be negative. So if I'm looking at this, right, I know that the tangent of 11 pi over 6, that's going to be equal to the tangent of 330 degrees, which is what I've got sketched here, which is v, right, over u, which in this case is -1 over the square root of 3. And again, I want to leave this as my exact answer, right? I will always be very clear about that when I'm asking my questions, like what's the exact answer of this? I don't want you to plug in, right, 1 over the square root of 3 into your calculator, because I want you to know, right, like this, yeah, it's approximately negative 0.577, but you could have gotten that just by plugging in into your calculator, like the tangent of 11 pi over 6. You need to be able to recognize those exact values, because sometimes you will be expected to, like, maybe do some things with those. You're going to cancel out a square root of 3 in something in calculus, right? We need to recognize the geometric shape of this thing to pull out these exact values here. That's the expectation in this class. So this, not going to cut it, right? There's no thought power that goes into finding that answer besides plugging in the tangent of 11 pi over 6 in radian mode into your calculator. I want to strengthen that logical connection of, right, what's going on that makes that. Okay, let's do maybe one more example. All right, we'll do another example. Let's say find the, I'll specify it here in the example too. Right, find the exact value let's do a tougher one, cosecant of 4 pi over 3. And you can't just plug this into your calculator. You can't go to Desmos, right? I want you to find this exact value in there. So we need to figure out, right, well, where is 4 pi over 3 on that circle? So I want you to pause the video here, try to do it yourself, and then I will work through the solution. Okay, this is how I think about this problem. I know that 4 pi over 3 is 240 degrees, or 30 degrees before 270, right? How do I know that? There's a few different ways, right? Again, I could do, say, 4 pi over 3, right, is 4 pi over 3s, right? So 4 60s, which would be 240 degrees. Or I can say, right, 4 pi over 3 is maybe 1 pi over 3 past pi. Right. So it's 60 degrees plus 180 gives me that 240 degrees, right? I'm trying to think of this. Again, you can do the rotations. I know it's 4 pi over 3. It's got to be a little bit more than pi. It's a 3 in the denominator, so it has the 60-degree reference angle. There's a lot of different ways that you can try to visualize this. Pick a way that suits you, whether it's the visualization of the circle, whether it's some form of the math that I've just done here, right? Whatever is going to work for you to figure out where this is in that circle, and then sketch it, right? Sketching always helps me kind of clarify these things, and if you get to a point where you don't need to, good for you, great, right? I'm not going to force you to all the time, but I know it helps me when I'm trying to get what's the big side, the middle side, and the short side. Right? So 240, 30 degrees away from 270, 60 past 180 is going to make this be my longer, my shorter, and my hypotenuse. Is anything negative? Well, I'm in quadrant 3 here. I'm this way there, like my u is going to be negative before the vertical axis, and I'm underneath the horizontal, so my vertical is also negative. I never, ever, ever make the radius negative when I'm doing these things. Right? The radius is just a distance from the origin to that point. Don't make the radius negative. Okay. So I've got my u, v, and r. And so now I just need to find what's the cosecant. Right? Well, the cosecant of this thing is the reciprocal of sine, so it's going to be r over v, which would be 2 over negative root 3. I'd really like it if you would pull that negative out front to get that, right? And there's my final answer. Again, I don't want an approximation. I don't want you to tell me it's negative 1.14, whatever it is there, right? leave it as that exact answer because that shows that visual thinking, that right logical connection steps here.